Hi, my name is Anderson Revenera. I am senior student of geoscience at Yacyretá University from Ecuador. I want to present a part of the project related to risk management and land use planning in rural areas of Ecuador, entitled Application of High-Resolution Digital Elevation Models for Landslide Susceptibility Mapping in the Urban Road Area of Urcuqui, Ecuador. In Ecuador, the lack of government regulation is generating the increase of semi-urban settlements in marginal areas to natural hazards like landslides. For that, this part of the project tried to identify landslide-prone areas to avoid that more people build their houses in those locations. As we know, geographical information systems and remote sensing are very useful tools for preparing landslide susceptibility maps. However, high-resolution data access is limited. Nowadays, an alternative at a reasonable cost is the use of drones for 3D mapping. Therefore, the objective of this part of the project is generate periodic DEMS to map and monitor areas of high vulnerability to natural hazards, like landslides. It is necessary because if we don't apply this type of mitigation studies to identify these landslides-prone areas, the local people will continue to build their houses without any restriction or preventive measures, which can turn into fatal events in the future. Methods. In this particular study, we are focusing on photogrammetry approach using drones. Pix4D capture software was used for double grid guided flights over an area of 340 por 200 meters, with some specific settings that are detailed in the poster. But also, we carry out fieldwork in the sun. This specific area is located at the northwest of Urcuqui city in the north of Ecuador. In these figures, we can see different views of the study area. Figure D shows a sketch of the areas that we identified: the landslides-prone area, the filling part, and the building lot. It is corroborated with the stratigraphic column, which mainly shows a sequences of primary volcanic deposits denominated as poorly cohesive soils. And in the right part, we have the active landslide area. In order to improve the orientation parameters and quantify the slip rates of mass movements, we implement our own ground control points, the figures F and J. Ground control points and the relative movement will be also measured with the Trimble total station, allowing direct assessment of the goodness of the drones based on subsidence estimates. It means that these reference points will serve to provide information on the relative morphology change. Unfortunately, due to pandemic situation, this project has not been finalized. Therefore, I am going to present you some of the preliminary results. I am going to mention the rest of the project as a study proposal. The preliminary results obtained are very favorable. The DEMS resolution achieved was 4 cm pixel. The figures I and J shows the numbers of overlapping images, and the figure K and L the digital surface models, which correspond to the post-processing images using Agisoft, Metashape, and Pix4D softwares. The computed DEMS are usually contaminated by large errors that result from the error of image matching. Therefore, the next step is solving the orientation parameters. Using the GPS coordinates of the ground control points, we carry out a manual calibration of the control points with the images. These points and measures serve to provide some of the information regarding the relative position of those points in the model. But we are not interested as much of the true accuracy of the model, but the relative. It means what is the change of the point clouds or DEMS between different months, and then to calculate the subsidence of the grounds on that. As conclusion, we have that the use of aerial photogrammetry using drones allow to extract DEMS with accuracy within centimeters scale at low cost. Relative subsidence throughout time can be without the use of ground control points, just throughout point clouds comparison in the post-processing part. However, the ground control points will be used in order to directly assess the goodness of the drones based ground movement analysis. Thanks.